Okay, so in this lecture, I'm going to talk you through some of the architecture stuff that goes on at the back of commercial websites. So commercial websites are, big internet scale applications that run across, thousands, tens of thousands of servers, have enormous quantities of data, do big scale data processing. So they're a very good example of an internet scale application. And they've also, and that's one of the reasons why we've got this mini project, which I talked about earlier, which you're doing this term, because that's like a sort of mini version of some of the technologies that go on in commercial scale websites. So in this website, we're going to summarize some of the key technologies. So we're going to look at server-side scripting, which is linked up with static versus dynamic, how server-side scripts use databases, need for content management systems, caching. I think got a little bit of stuff on Akamai, and some of the other sort of things that go into building a commercial scale website, such as search engine optimization, analyzing traffic, and the APIs that websites such as Amazon and eBay make available for other businesses to sort of use to sell their products through their websites. So a little bit of motivation. So here's like a Java development job. So that's covering quite a few of the technologies I'm going to talk about and covered in this course. So we're not going to really talk about Spring much, but I'm going to talk about Hibernate today. I think these are, so this is all, straight up the sort of things you're doing in a mini project. And Linux, well, maybe you're doing that in some other course. But as a junior sort of back-end web developer, there's lots of jobs out there in London for this kind of stuff. You probably wouldn't make 35, 40, you'd probably be looking a little bit lower just as you're starting. But there are jobs in this kind of technology. Okay, so static versus dynamic. So when you're browsing a website, you type in the URL into your browser. I explained earlier how the DNS system converts the string into IP address, and then the browser sends to that like HTTP GET request to that IP address, and then they get some HTML. So that what goes on at the back end of a commercial scale website is a whole load of really complicated processes, big scale processes, but the end product of all that is just a little bit of HTML that's sent back to the user. And that HTML might be a newspaper's website, it might be like the Facebook front page, it might be Gmail, but bottom line is it's all just HTML with a little bit with CSS and a bit of JavaScript. Now with a static website, so in the lab sessions, when you're doing your first sort of index HTML page, you're writing down a bunch of HTML and saving it in a file. With a static website, all the web server does is it goes to that file, loads up the HTML, and sends that back to the user, to the client that requested it. So this is a very simple model here. Here's the client, you on your browser or whatever. You send a GET request to the server, and that GET request is directed to a particular file on the server. The server looks inside that file, pulls out the HTML, and packs it into an HTTP response message. Easy peasy. The HTML is always the same, but very few commercial scale websites. Well, no commercial website works like that, and most other websites don't work like that either. On most websites, what happens is the HTML is dynamically generated in response to a client's request. And that uses several different technologies. We've got server-side scripting languages, which we can talk about. There's a lot of databases sitting at the back of commercial websites. And there's a lot of dynamic interaction with the user with JavaScript and Ajax these days. So start with the server-side scripting. So if you're building your website at home, you're soon going to run into the problem that many of the pages that you're building have a similar content. So maybe you've got like navigation bars, maybe you've got a footer, maybe you've got something down the side, like a sidebar, something like that. Maybe you've got background. There'd be a lot of highly similar content on many of your pages. And when you first start web development, you're going to cutting and pasting that content onto all the different pages. But if you've got 20 pages, it soon becomes an absolute nightmare to maintain. You get the same. You make a change to the navigation bar and you paste it across 20 pages. It's a lot of work, and there's a lot of room for errors creeping in. It becomes a pain to update the site, to change the look and feel of the site, and so on. So looking at Middlesex's website, so here this is all the same on every page. This top bit here, and this sidebar here is also identical. There's probably might be even some stuff at the bottom. So I've got two pages. It's got exactly the same content on both of the pages. So to get around this problem, we can use server-side scripts. So server-side script is executed by the server. When it receives the GET request from the client, it executes a script or program, whatever, and that program dynamically generates the HTML either from scratch or in combination with specific little chunks of HTML that are embedded in the script, as I'll explain. So this enables you to dynamically create HTML like on the fly, and you could have like a function that outputs the menus, and that function could be present on every page, and the code for that function could just be in a single place, so it'd be much easier to update the navigation bar or that kind of thing. And as I'll explain later, these scripts are used to access and update but databases. There's like a wide range of functions you can do with these server-side scripts. So this is the sort of static website. We send the GET request. The server sends back the contents of the index HTML. But this is a much more realistic website scenario. So here you have the client sends the GET request. This GET request is channeled to a particular PHP script, for example. It's one of the server-side scripting languages. That PHP generates some HTML, and that HTML is then sent back to the client. So this is on my personal website. This is what I use to get around this problem of duplicated navigation bars and footers and so on. And it works a treat. I mean, it's really, PHP makes your life a whole ton easier. I'm not using databases on my personal website, but I'm just using it as a way of dynamically generating stuff and making it much easier to maintain. So there's lots of different server-side scripting languages. So PHP is like classic one, still probably use the majority of websites. And they've got Java server pages. This is a sort of weird mixture of Java code and an HTML code in the same file. I don't think it's used that much. I don't like it that much. But if you ever see a website with like JSP, or I think it's JSP extension, then they're using Java server pages. Then we've got .NET, C# stuff. Don't know anything about that. Cold Fusion, some kind of ancient server-side scripting language I worked on Trinity Mirror. Awful stuff, and you have to pay for it anyway. Python's becoming a bit more popular, and a really big one now, or emerging one now, is server-side JavaScript. So you have like Node.js, which like executes server-side JavaScript. So you can have JavaScript both on the client and the server side with Node. So PHP is pretty popular, free and easy to use, fully fledged programming language, and a bit fiddly to run in NetBeans. It's not part of this course, but I'm just giving you a little bit of an illustration of how it works here. And what you do is you have these special tags. So the tag opens with $PHP and ends with a question mark. So you put all the PHP code in these tags, and the rest of the page can be HTML. So just to give you a little example of how you could use this, here we have like a little sort of shopping page. So this is the kind of banner, the header with the navigation here, and then this is the contents that changes with each different page. And this is how it would look if you just had static pages. So here we have the header, and here we have like the navigation bar here, and here is the content that's unique to the page, just in this little bit here. All the rest is duplicate. So suppose you want some PHP that outputs this, and then which would make it easy to update the navigation. We can change the look and feel of the navigation very easily if we're outputting it in a function rather than pasting it into each page. So we write a PHP function, outputs the banner and menu, and then we tweak the output so we can do the highlighting of the links. So if you look here, we've got like, this tells us we're on the home page, and that's using this class selected here. So whichever page we're on, we're putting selected so that it changes the color of the link that of the page we're on. Yeah, so this is one product page, and here the products link is the one that's selected. So this is how the page looks once we've added the PHP in. So sorry, no, this is the PHP. This is the separate PHP function that exists in a separate file, and then we invoke this PHP on each of the pages. And all the PHP is doing is echoing like the banner or whatever, the top banner bit, and then here it's echoing the navigation bar. We don't worry too much about the details, and then if it's found the appropriate page, it'll highlight make sure that the links are highlighted appropriately. So we've got this generic PHP function that outputs the menu on the top of the page, and then on each of the pages, we just have to have this little bit of PHP code here that outputs the menu and specifies which page we're actually on. So our pages are dramatically simplified, and we've just got a single function that outputs the menus. Okay, so that's just explaining how server-side scripting can improve the maintainability of your website by outputting different bits dynamically. Now we can look at how the server-side scripts interact with databases in order to generate more complex dynamic content based upon the user or based upon other stuff, as I'll explain. So on a commercial website, most of the contents of that website are stored in databases, either traditional databases or moving increasingly towards the cloud. So if you've got a news site, you might have like the users, passwords, of both the sort of regular sort of members of the public, but also of the journalists, that kind of stuff. You might have the news stories, you might have images, videos, and so on. All of that is going to be some dirty great set of databases, and we've got a whole lecture on databases to go into that in more detail. So this is the situation when I worked at Trinity Mirror. They're big databases that stored all this kind of stuff. And to pull the data out of the databases, we're using server-side scripting languages or possibly programs written in Java. So Java's got stuff for that, as I'll talk about Hibernate, but we might also want to use server-side. So Java's not a scripting language, that's a compiled language, but so we could use either Java or we could use PHP, server-side JavaScripts and so on. So now this is the kind of model we get. So here we have the client sitting there, typing the URL, sending that GET request to the web server. The web server has this PHP now that receives the request, and the PHP is going to interact with the database. It's going to pull data from the database, assemble that data into HTML, and send back that HTML to the client. So that's how it works. So suppose we want to display a news story, right? I've typed the Guardian homepage or whatever, and just select a particular story to view. So we're going to have to do multiple calls to the database in this case. We're going to have to pull out the headline maybe the text of the news story, maybe some images, maybe related stories, so you can suggest some other stories to the user at the bottom. And maybe there's going to be some information about the journalist, like a little biography of the journalist as well. All of that be stored in separate fields in different tables, different databases maybe. And the server-side script or the server-side programming language is going to pull all of that data from these different databases and assemble that into the HTML that you actually view when you look at a news story. And that's what's sent back to the client. So just to give you an example with PHP, how this all works. PHP is a classic. There used to be, a few years ago, the combination was like PHP, MySQL database, is LAMP, right? So Linux, Apache, so Linux operating system, Apache server, PHP and MySQL, like the LAMP stack within which PHP was the crucial part. So PHP is great for interfacing with databases. You can embed PHP in SQL in PHP, and there's like this PHP Data Objects as well. I'm just going to give you a very simple example to show you how it works. So here we have these PHP variables storing all the username, passwords, and so on. And then we connect to the database, all very straightforward. And then we just have this SQL. This is like a PHP variable, like select ID, first name, last name from my guests or whatever. And then we execute that on the database, get back a result. We work through the results and convert that into like HTML and echo that back to the user. Very simple. So yeah, that's the SQL statement that we're executing in the database, and then we execute that in the database, and then we work through converting that into HTML, and that HTML is sent back to the client. So web services, so servlets work very nicely with databases. You can use Java. I said you can use PHP. We can also use programming languages such as Java to execute SQL statements and process the results. And Java has this very nice feature called Hibernate, which again we're moving towards the enterprise systems here, that you can use in Java to, it's a sort of interface between Java and the database that makes it much cleaner and easier to use databases in Java. So Hibernate's this free Java library, maps between Java objects and the database. So it's a kind of middleware. So as a Java programmer, what you interact with are Java objects. And what the middleware ensures that there's a mapping between these Java objects and the database. So if you change these Java objects, you're actually changing the fields in the database, and these Java objects, when you initially load them up, reflect the fields in the database. So Hibernate does all the messy SQL stuff behind the scenes automatically, and once it's configured, it works very nicely. So this is the general idea. Here we have a database, a bunch of like clever stuff in Hibernate, and then here we have the actual code that the programmers are writing. And what they do is they interact programmatically with a persistent object, and then behind the scenes, Hibernate makes it all work nicely, such that this persistent object reflects an object in the database. So Hibernate has this XML, like various configuration files that specify, what are the tables, what's the data, what are the classes, and how do we connect to the database. So you need to set the whole thing up. It's a little bit complicated. So we need the usernames and passwords. We need to say which classes hold the data, and the mappings between the database fields and the variables in the persistent class. And in the end, once we set it all up, then we can write the code that manipulates the classes. So this is the sort of thing it looks like. So here we have like a configuration file where you've got like the connection, username, password, and so on and so forth. Then we've got the persistent class. This is just a very simple Java class. This is what we interact with when we want to make changes to the database. So in this class, we might say we want to change the name of the user. So we set first name, or we get first name to retrieve it, or we get the last name and set the last name. Standard class with lots of getters and setters. A little bit like a bean, I guess. It might even be a bean. And then we've got a mapping between the fields in this class and the fields in the database, which again we set up using an XML file. And then in our actual code, we can create a new employee, which is effectively creating a new entry in a database. And then we can set the values of this employee, such as the name and the ID and so on. And then as we do this in the Java, it'll behind the scenes will be mapped onto the database and then stored in the database. And at a later point in time, you can retrieve this employee just using the simple Java code. Okay, so that's a little bit about the database interactions. Now I'm going to talk about how the content actually gets into the databases. So I gave the example of the news story. We got like news, images, videos, and all the rest of it coming out of the database, but how does all that stuff get in the database in the first place? Well, some might be imported automatically, so maybe using web scraping, web crawling, so on. So Google has an absolute ton of stuff in their databases, but most of that comes from the Google web crawlers, the spiders, whatever, who systematically work their way across the web, building up all that data in their databases. But a lot of other sites, that data, for example, news site or Tesco's, for example, all of that data doesn't come from web scraping. It has to be entered manually somehow. So, the users could write SQL, right? A journalist could come back from, Scotland or whatever with a new exciting story, and they could write some, insert into, my stories. They could write all the SQL, but, they're bound to mess it up, and they'd have to learn SQL. It's much easier, and what everyone does is they have a separate interface that enables people, non-technically skilled users, to enter information into the database. And that's what a content management system is. It lets people change data in the database. So you might have a page that lets people add a story to the database, or let people edit a story in the database, and so on and so forth. And then when you've added the story to the database, they can automatically appear on the newspaper's website. And the same with products, right? Tesco's will have a product inventory management system kind of thing, and users somewhere or other in that gargantuan system will be able to say, well, let's add a new type of broccoli to the database, and there'll be a little page, and you add a little picture of the broccoli, and so on and so forth. So it's typically a web interface. I mean, it could be Java, Swing, FX, whatever, but it's typically a web interface for doing this. So this is the sort of picture we had originally, and what we're adding here is our content management system. So you have a client with a special login thing, special reporter thing, or special Tesco staff login, whatever, and they're sending a GET request to another bit of PHP. That PHP enables them to view the contents in the database and to add things to the database. And again, this is accessing things in the database, generating HTML, sending it back to the user. So here you have the loop, and in this loop, this client is adding, deleting, editing, whatever, the material that's in the database, and then that material in the database is then being displayed to the client. There's various free ones. I mean, a lot of websites are built using CMSs. So you've got Drupal, WordPress, Joomla, and that enables you to build your own websites and edit and update the content on those websites. Okay, caching. So some websites are extremely popular, right? BBC News, who knows how many views they could get across the world. And all of this complicated stuff takes a lot of time, right? You've got database accesses, you've got execution of scripts, you've got handling of different requests, response, all the rest of it. None of this happens that particularly fast. And if you've got millions of requests per second, there's no chance that a single server could possibly do all that and deliver all the content in the time available. So one way in which you can handle this problem is by dynamically generating the page once. So you do all the complicated database queries and all the rest of it for the BBC homepage, and then you using PHP databases or whatever, and then that's generating a piece of HTML with the CSS and JavaScript files, and then you can just cache multiple copies of that because it's not changing much. So you can just duplicate that HTML all the way around the world, wherever you like, and everyone can just access that more rapidly because you can distribute that copy across multiple machines. So this is no caching scenario where you're doing all this kind of complicated stuff at the server in order to generate the HTTP response there, but that takes a lot of time. One server can't possibly cope. So what's done typically is we have a caching layer here, and the client interacts with the cache, and it's the cache that delivers this HTTP response. And then periodically the cache will send a GET request to the server and get the response sent back to make sure that it's got the up-to-date information. So this can handle the millions of requests per hour, and then maybe it'll send one request per hour to the actual server that's generating the HTML. In that way, the cache can stay up to date, and then the cache itself can be a much bigger system distributed across lots of different machines, and deliver it efficiently to the user. So there's various caches out there. So Varnish and Squid are kind of software I think you can install and deploy yourself. And I'm going to say a little bit about Akamai because that's like an interesting internet scale application in its own right. So Akamai, it's big. It's like 15 to 30% of all web traffic. That's just an enormous amount of traffic it handles. It's a network of 175,000 servers, more than 100 countries. So this can deliver content on a really vast scale, right? And it works by distributing the customer's content closer to the users. So like with the BBC example, so there'll be people across the world who'll be accessing the BBC website, but the people in Australia will probably be accessing the BBC website from the Akamai cache in Australia, and the people in America from the Akamai cache in America, and so on and so forth. And they have clever mechanisms by which the servers check each other caches, update each other, and actually pull the original website if they need it. And this is all done through DNS. So instead of the domain name system resolving, let's say the user types in bbc.co.uk. I don't know if BBC does use Akamai, but let's suppose it does. And so they type in bbc.co.uk to get the homepage, whatever that is. And the DNS server, in the way I discussed previously, would resolve that to the BBC server, right? And then they talk to the server and get the HTML. But if they're using Akamai, the DNS system will resolve that DNS request to the nearest Akamai server that has that content. So the DNS system will return the IP address of an Akamai server, not the IP address of the BBC server. And then the customer will contact that server and download the content directly from the Akamai server. So through DNS, it enables the customer to find the nearest server that has that particular content. So it's a pretty neat system as well. And so that's the customer of Akamai, and here are the end users. And then you have this enormous 175,000 servers distributed across the world. And then so the DNS system will resolve to, let's say, this server and pull the data from there. And then this edge server will periodically pull the fresh content from the customer service. In this case, this would be the BBC server in this example. Now, this is nice and simple and easy for pages that don't change much or change once every half hour, let's say. That's no problem whatsoever because you have a single server that generates the HTML every half hour, easy peasy, and then that's content's cached across the world, and the user gets it very quickly. This is much more tricky with content that changes all the time. So let's suppose Gmail, you're constantly changing your display of the emails that you've just received, or Facebook, your timeline's constantly changing. So Akamai has algorithms that can deal with this, and it can route the customer requests along the fastest route. So it can handle it to some extent, but it's a more complex challenge than just simply caching a bunch of HTML. Okay, so this is, if you're a commercial website selling something, then search engines are a key way in which your customers are going to find your product online. So if I'm selling cabbages, let's suppose, I make all these fine cabbages in East Anglia, or grow them rather. When someone searches, for cabbages for sale, I want them to find my website rather than my competitor's website, so that they click on my link first and buy my cabbages, right? So you can pay for keywords or whatever. You can pay for keywords here as well, I think. But it'd be kind of nice if you just appeared first on the first page of a search for cabbages if you were trying to sell cabbages, that is. And in order to achieve a high ranking in the search results, you need to take into account how the crawlers that get the data about different web pages actually work. So how, if you've got a website selling cabbages, how has Google found your content? Which parts of the site can it access? Which parts of the site can't it access? What kind of document types does it support? So if I had a cabbage website that was all in images, then Google wouldn't be able to understand it, and it would be completely useless from a web crawler point of view. On my website, I've got quite a lot of content in JavaScript that has to be executed by the browser, and that's not indexed in Google either. So you need to take into account how the web crawler works if you want to get high rankings or appear in the searches that people type into Google. And this is Google PageRank algorithm is what made Google big. I'm sure they've tweaked it an awful lot, but probably the core of it is still present to some extent in the way Google organizes and chooses which pages to put above other pages when the user does a search. Because the user wants to find the most relevant and interesting pages for their search, but which is slightly in conflict with the demands of the businesses who want to appear first so they can make more money. So Google is oriented towards the users, and that's why they're using this PageRank algorithm so that the user gets the most relevant searches for their results for their query. As I said, PageRank is how they started, but there's probably a lot of other strategies, some of which they keep quiet so people can't game the system too easily. So this is the idea. The PageRank algorithm, the pages that are higher in the ranking are ones that have other high-ranking pages linking to them. That's the basic idea. So if you have lots and lots of pages linking to you, and all of those pages are really important, then you're going to get you'll appear higher in the listing on Google. Whereas if you've got no one linking to you, then who cares about you, right? So you're going to fall off the bottom of the Google searches. So here, the size of the little smiley face corresponds to the importance of the website and the ranking of the website. So this one would appear top in the search listings. This one would be second. One of these would be third. And this would be fourth. One of these would be fourth, and these would be fifth. That's the rough idea. And so a website that has lots of other websites linking to it will itself have a higher, ranking value, whatever it's called. But also the importance of the websites that are linking to is taken into account in the algorithm as well. So this one's quite a big sort of smiley face because it's got 1, 2, 3, 4, 5 small ones and one big one linking to it. So it's quite big, it's quite important. But this one's really important. This one has also got 1, 2, 3, 4, 5, 6, 7 websites linking to it. But also, these are quite important websites in themselves. So this is a big one linking to this one, and so that's taken into account in the rankings. And so if we look at carefully, I think we've got so this one's only got one link going to it, for example. But because this is a link from an important website, then that increases its size, whereas this one's only got a link that's bigger than that one, because this has got a link from an important website, and this one's got a link from a less important website. And this is what you expect, right? If my homepage, let's say, my personal website, had lots of links from the BBC, lots of links from the Guardian, lots of links in the Times, then it'd be kind of reasonable to suppose there was something important and of interest on it, and that if I had keywords cabbages for sale on my website, then it'd be reasonable to suppose that what I had to say about cabbages and their selling would be of importance because of all these links from other sites. Whereas someone who just creates a website that's cabbages for sale, no one cares about it, no one links to it, just sitting there sadly on its own, well, maybe if no one else thinks that's important, why should Google return that as an important link in its search results? So if you want to be the big yellow smiley face rather than the small green, slightly less smiley face, how do you go about it? How do you actually raise your rankings? And this is called search engine optimization. So there's many legitimate techniques recommended by search engines. So you can have like a sitemap, because your website's indexed by bits of code that look at the HTML and look at keywords and all this kind of stuff. So if you've got a sitemap, it's easy for the web crawler to find the different parts of your site. Obviously, if you can persuade the BBC and the Guardian and so on to link to your site, then that's going to increase its ranking. Update content frequently, that's taken into account in the algorithm. And you're being ranked on the content of the site. Where you rank depends on the connections to your site, but this is the the actual, Google's trying to return websites that are relevant for particular queries, right? For cabbages, for robotics, for computer science, whatever. So you need to have relevant keywords on your site and metadata, perhaps, so that's less important now. Because these web crawlers are actually going to look at the content and use the content plus the links to your site to provide the final ranking. And then a lot of companies used to, and probably still do, offer to increase your rankings or try and increase their own rankings through a bunch of strategies that are not regarded as legitimate, not recommended by Google. So you can do things like create dummy websites linked to your site. So you might create a bunch of fake websites that all have links to your site in order to increase the ranking of your site. So you have keyword stuffing, so you increase the count of particular keywords on your website. You might put cabbages 1 million times to try and increase your ranking of cabbages. You might have hidden text, this kind of linked to keyword stuffing, so you might have words that would appear to the user, but they're colored the same as the background. So the web crawler would find them, but the user wouldn't see them. Doorway pages, so you can hack your website like front end, the first page the user comes to, in order to make it highly search engine friendly, and then but pretty user unfriendly, and then the user kind of clicks on it and goes through to the main website, which is probably quite rubbish for them. Or cloaking means that you have one page that appears to web crawlers. It senses whether it's being viewed by a web crawler or by a human and provides a web crawler friendly site to the web crawler and a human friendly site to the human in order to get higher rankings on the web crawler site. These strategies are dodgy, not recommended by Google, and they can also lead to you can be penalized, right? If Google detects that you're trying to spam using lots of dodgy spam indexing strategies, it's going to decide that your site's probably not worth the user having a look at, and it could give it a very low ranking, kick it to page 10, which no one looks at, make it effectively invisible on the web. And so these are big risks, and so I wouldn't recommend you try spam indexing strategies. Okay, another aspect of websites, commercial scale websites, is web analytics. So companies are spending enormous amounts of money on all these databases, all the technical stuff, all the scripting and programming, all the rest of it, to build these commercial scale websites. So it's extremely important to them to know how customers are interacting with these websites so they can fine-tune them to make them more customer friendly, to increase the sales rate and all this kind of stuff. So there's various tools used for web analytics that enable companies to monitor how companies are interacting with their site. So they can, for example, using web analytics, they could suppose they had a new sales campaign in Argentina, let's suppose, and no new sales campaign in Chile. So using web analytics, they could see whether their sales campaign had an impact and increased the number of people visiting and number of people purchasing things on their website in Argentina as opposed to the website in Chile. So increased purchases and clicks, and monitors customers' response to new advertising campaigns. So that's the sort of idea. And you can even produce different versions of the site to randomly selected customers, and then monitor whether the randomly selected customers, if the version's been changed in some way, whether it increases the click rate or changes their browsing patterns on the site. So maybe you want to know how many people are using the site, where they're from, what browsers they're using, what behavior, right? Have they added stuff to the basket and then decided not to go through with the purchase? In which case, why was that? Was it something to do with how you presented the request for credit card information? Was there something to do with the price? What was leading them to abandon the sale halfway through? So one tool for this, an absolutely brilliant tool for this, is Google Analytics. It's very easy to install on your site, so it's a bit of JavaScript, but if you're using server-side scripting to generate the site, you just have to include it just in your function that generates the website. Simple web tracking code onto each page, and then Google enables you to have a really detailed breakdown of the different users, different countries they're coming from, and all the rest of it. So you can do absolutely stunning stuff. You can see how many sessions, users, and drill down to the different pages they're viewing and all the rest of it. It's an extremely powerful tool and the sort of thing commercial websites use a lot. So I think this is like the behavior flow, how are they interacting with the site? They look at the home page, and then maybe they go to a different page, and another page, and so on and so forth. All right, finally, I just say a little bit about web APIs. So in your mini project, you've got this little web service that you're building using the servlet. And web services enable, customers, clients, or businesses actually, to embed their content in other websites. So you can, there's stuff about, Facebook links, Twitter links, all the rest of it, Twitter contents. You can embed images, videos, Facebook buttons, booking forms, and so on and so forth. So ways in which one website's content can be embedded in another website, or the content from from one business can be. I'll explain that later with the Amazon stuff. All right, so this is just a little simple example. So this is a web page I built for my parents a while ago. And here we have a little bit of third-party content here, which is like a booking form from a third party. And this company has like a bookings service which enables you to book a room. And my parents had this account with this booking company so that you could like enter the form, see the availability and so on. And it had a back end that you could use to adjust the bookings and enter bookings manually and so on. So it's just a little bit of embedded content. In this case, using a web frame, I think. But with big commercial websites, you've got lots of web services. So this is a fairly unsophisticated way of doing it, just using HTML. But you could actually do it using like a proper web service. So if you've got like Amazon Marketplace, eBay, Facebook Graph, these big companies have ways in which you can programmatically change the content of the website. So on Amazon Marketplace, you can use their web services to put products for sale, produce inventories, and so on and so forth. And so, if you do a search for, that's distributed systems paperback, you've got a bunch of other companies who are all offering the same thing, and I'm guessing that this is all coming from web services that they're using to add and interact with the Amazon content. So you can list items for sale on Amazon, manage your inventory, manage orders, generate reports, track shipments, and so on and so forth. And then the eBay also has an API which gives you the current list of eBay categories, information about items listed, bidder information, list of items, so on and so forth. Lots of stuff you can do to programmatically interact with eBay using their web services. And Facebook Graph has a ton of stuff for updating status, adding posts, uploading photos, and so on. So you could write your own app that uses Facebook Graph to change your Facebook account, for example. Okay. So the idea of this lecture has been to take a commercial website as an example of an internet scale application and give you a little bit of a breakdown how the different parts of it work and how, the sort of architecture, technology, that kind of stuff of a commercial website. And I hope that'll give you some idea about where your first mini project's aiming, because it's sort of aiming at the sort of general technologies that are going on with commercial scale websites. Next lecture, we're going to talk about some of the security issues with internet scale applications. And so, see you next time.